morning, grade 11 Senior High School of Kawayan City National High School. Welcome again to General Mathematics. For today's video lesson, we will talk about exponential function. Our objective for this video lesson is to solve exponential equation and inequalities. Represent an exponential function through its table of values, graphs, and equations. Find the domain and range of exponential function. Determine the intercepts, zeros, and asymptotes of an exponential function. Let's recall the definition of exponential expression. It is a mathematical expression which contains an exponent. This expression can be written as a multiplied to b raised to x minus c plus d, where a, b, and d are constant. The value of b must be greater than d but not should be equal to 1, or b must be greater than 0 and b must not equal to 0. Exponential function. It is a function that can be written as f of x is equal to b raised to x, or y is equal to b raised to x, where b must be greater than 0 and b must not be equal to 0. Exponential equation. It is an equation involving exponential expressions. The base must be constant and its exponent must be containing a variable. Exponential inequality. It is an inequality involving exponential expressions. The base must be constant and its exponent must be containing a variable. Note: the exponential equation and exponential inequality can be solved for all values of x that will satisfy the equation or inequality, while the exponential function will just show us the relationship of two variables. Let's proceed to one-to-one property of exponential function. If x sub 1 is not equal to x sub 2, then base having exponent of x sub 1 is not also equal to the base having the exponent of x sub 2. Conversely, if base having an x sub 1 is equal to the base of x sub 2, then x sub 1 is also equal to x sub 2. Let's solve our first equation, that is 4 raised to x minus 1 is equal to 16. As you notice, we have different bases, that is 16 and 4. We'll make 16 equal to our first base, that is 4 raised to x minus 1 is equal to 4 squared. 4 squared is equal to 16. As you notice, we have now the same bases, that is 4. And when we have the same bases, we will focus on our exponent, that is x minus 1 is equal to 2. Okay, and then we will now solve what is the value of x. Okay, so we will transpose negative 1 to the other side of our equation. That will make us x is equal to 2 plus 1 and x is equal to 3. And that is our final answer for this example number 1. Let's make the alternate solution for the equation 4 raised to x minus 1 is equal to 16. That is 2 squared, that is equal to 4 raised to x minus 1 is equal to 16 is 2 raised to 4. We have the same bases, so we will focus on the exponent, that is 2 multiplied to x minus 1 is equal to 4. Let's simplify it. 2 multiplied to x is 2x. 2 multiplied to negative 1 is negative. 2 is equal to 4. Let's simplify. 2x is equal to 4 plus 2. Then 2x is equal to 6. Divide both sides by 2 for us to have the value of x. Okay, cancel 2. X now is equal to 6 divided by 2 is equal to 3. And that is the final answer. Let's solve our second equation, that is 125 raised to x minus 1 is equal to 25 raised to x plus 3. We'll make our bases equal to each other. 125 is equal to 5 cubed multiplied to x minus 1 is equal to 25 is a perfect square of 5, that is 5 squared multiplied to x plus 3. As you notice, we have the same bases, so we will now focus on our exponent, that is 3 multiplied to x minus 1 is equal to 2 multiplied to x plus 3. Let's simplify our equation, that is 3 multiplied to x is 3x and 3 multiplied to negative 1 is negative 3 is equal to 2 multiplied to x is 2x, 2 multiplied to 3 is positive 6. Let's simplify again. 3x transpose positive 2 to the other side will become negative 2x is equal to 6. Transpose negative 3 to the other side of our equation, that is positive 3. So 3x minus 2x is equal to x, and 6 plus 3 will give us a value of 9, and that is our final answer. Okay, so let's solve our third equation, that is 9 raised to x squared is equal to 3 raised to x plus 3. Let's make 9 equal to the second base, that is 3 squared raised to x squared is equal to 3 raised to x plus 3. Since we have the same bases, we will focus on the exponent, that is 2 multiplied to x squared is equal to x plus 3. Let's simplify it, that is 2x squared is equal to x plus 3. And then we will equate that to 0, that is 2x squared minus x minus 3 is equal to 0. Okay, 2x squared minus x minus 3 can be factored, and the factors are 2x minus 3 multiplied to x plus 1. Okay, that is a factor of 2x squared minus x minus 3. To check, 2 multiplied to x is 2x squared. 2x multiplied to 1 is positive 2x. And then negative 3 multiplied to x is negative 3x. Negative 3 multiplied to 1 is negative 3. That is 2x squared minus x minus 3. And they are the same. Okay? So, let's have the two values of x. That is 2x minus 3 is equal to 0. 2x transpose negative 3 to the other side, that is equal to 3. Divide both sides by 2, cancel 2. X now is equal to 3 halves, our first x. For our second x, that is x plus 1 is equal to 0. Transpose positive 1 to the other side, that is x now is equal to negative 1. And that is our final answer. Property of exponential inequalities: if b is greater than 1, then the exponential function y is equal to b raised to x is increasing for all x. This means that b raised to x is less than b raised to y if and only if x is less than y. If 0 is less than b and less than 1, then the exponential function y is equal to b raised to x is decreasing for all x. This means that b raised to x is greater than b raised to y if and only if x is less than y. Let's solve the inequality 3 raised to x is less than 9 raised to x minus 2. As you observe, both 9 and 3 can be written using 3 as the base. That is, 3 raised to x is less than 3 squared raised to x minus 2. Let's simplify it. That is, 3 raised to x is less than 3. 2 multiplied to x is 2x. And 2 multiplied to negative 2 is negative 4. Since the base 3 is greater than 1, then this inequality is equivalent to x is less than 2x minus 4. Let's simplify it. That is, 4 is less than 2x minus x. And then 4 is less than 2x minus x is x. For our final answer, we will write it in a solution set, and that is x is the element of real number such that x is greater than 4. And that is our final answer. Let's solve the inequality 1 all over 10 raised to x plus 5 is greater than or equal to 1 all over 100 raised to 3x. Since 1 over 100 is equal to 1 all over 10 squared, then we will write both sides of the inequality with 1 over 10 as the base, and that is 1 all over 10 raised to x plus 5 is greater than or equal to 1 all over 10 squared raised to 3x. Let's simplify it, and that is 1 all over 10 raised to x plus 5 is greater than or equal to 1 all over 10. 2 multiplied to 3x is 6x. Since the basis 1 all over 10 is less than 1, then the inequality is equivalent to x plus 5 is less than or equal to 6x. We will simplify the inequality, and that is 5 is less than or equal to 6x minus x. Simplifying it, that is 5 is less than or equal to 6x minus x is 5x. We will divide both sides by 5 for us to get the value of x, and that is cancel 5, cancel 5. 5 divided by 5 is 1. It's less than or equal to x. For our solution set, that is x is element of real number such that x is greater than or equal to 1. And that is our final answer. Exponential functions can be represented through its table of values, graph, and equation. The data in the table of values of an exponential function has a common factors and equal intervals as shown in the diagram. These data of the values are important in sketching its graphical representation, which will describe the behavior and characteristic of the function. Let's have our example. Represent the exponential function through its table of values and its graph. That is, y is equal to 2 raised to x minus 5 when x is equal to 0, 1, 2, 3, and 4. Let's solve our table of values. That is, at x is equal to 0, here y is equal to 2 raised to 0 minus 5. And that is y is equal to 2, 0 minus 5 is negative 5. Let's make it in fraction form, that is 1 all over 2 raised to 5. And then 1 all over 2 raised to 5, that is 1 all over 32, or 0.03125. We will put it out in our table of values, that is 1 all over 32, or 0.03125. 3. Yan. So at x is equal to 1, our y is equal to 2 raised to 1 minus 5. And that is y is equal to 2, 1 minus 5 is negative 4. Again, we will put it in a fraction form, that is y is equal to 1 all over 2 raised to 4. Our y now is equal to 1 all over 16, or 0.0625. We will put it in our table of values, that is 1 all over 16, 1 all over 16, or 0.0625. At x is equal to 2, here y is equal to 2 raised to 2 minus 5. And that is y is equal to 2 minus 5 is negative 3. And that is, again, we will put it in our fraction form. That is 1 all over 2 thirds. 2 cube. That is y is equal to 1 all over 8. Or 0.125. Okay, we will put in our table of values. That is 1 all over 8 or 0.125. Okay. At x is equal to 3. That is y is equal to 2 raised to 3 minus 5. And that is y is equal to 2. 3 minus 5 is negative 2. Fraction form. Okay, that is 1 all over 2 squared. That is y is equal to 1/4 or 0.25. Again, we will put it in our table of values. That is 1/4 or 0.25. Yan. Okay, last. At x is equal to 4, our y is equal to 4. That is 2 raised to 4 minus 5. That is y is equal to 2 raised to negative 1 in the fraction form. That is y is equal to 1 all over 2. Let's have our imaginary 1 as an exponent. Okay, so simplifying it, that is y is equal to 1/2 or 0.5. So that's it's 1/2 or 0.5. So we have already our table of values. Exponential functions have several applications to real-life problems. These functions can be used, for instance, to solve problems pertaining to population growth, radioactive decay, and investment with compound interest. Exponential growth and exponential decay gives mathematical model that involves power of e. For instance, to solve problems pertaining to population, where b and k are positive constants, that describes an exponential growth. Similarly, a function defined by an equation of the form f of t is equal to b e raised to negative kt, where your t must be greater than or equal to 0, where b and k are positive constant, that describes an exponential decay. In particular culture tests, if f of t bacteria are present at the t minutes, then f of t is equal to b e raised to 0.04t, where b is a constant. If there are 1,500 bacteria present initially, how many bacteria will be present after 1 hour? When t is equal to 0, our bacteria f of 0 is equal to 1,5, wherein we will use that to our formula f of 0 is equal to be raised to 0.04t. Okay, so we will substitute the value of f of 0, that is 1,500, is equal to b e raised to 0.04 multiplied our times 0, that is 0. Simplifying it, that will become 1,500 is equal to b and then e. 0.04 multiplied to 0 is 0. And that is 0, e raised to 0 is 1. Okay, that is 1,500 is equal to b times 1. And your b is 1,500. Okay. Let's convert first 1 hour to minutes, and that is we have 60 minutes in 1 hour. So when we have our function f of 1 hour, that is 60 minutes, our b of e raised to 0.04 multiplied to 1 hour, that is 60 minutes, that is our new function. Okay, simplifying it, we will now have what is the value of b, that is 1,500 raised to 0.04 times 60, that is 2.4. Using your calculator, we can simplify 1,500 e raised to 2.4, and that is 16,535. Therefore, there are 16,535 bacteria present in the culture test after 1 hour. For our next example, if G of T pesos is a value of a certain piece of equipment in T years after its purchase, then G of T is equal to B E raised to negative 0.20 T, where B is a constant. If the equipment was purchased for 8,000 pesos, what will be its value after 2 years? Okay, let's solve. When T is equal to 0. When T is equal to 0, our G of 0 is 8,000 pesos initially. Okay? So we will now have the function G of 0 is equal to B E raised to negative 0.20. What is our time? That is 0. Alright. So our G of 0 is 8,000. Is equal to B E negative 0.20 multiplied to 0 is 0, and E raised to 0 is equal to 1. That is 8,000 is equal to B multiplied to 1. And that is, simplifying it, 8,000 is equal to B. So we now have the value of our B. So let's have our T when T is equal to 2 years. So we have G of 2 is equal to, what is the value of our B? That is 8,000. E raised to negative 0.20 multiplied to our time, that is 2. Okay? So we have now our function G of 2 is equal to 8,000 E negative 0.20 multiplied to 2 is negative 0.40. Okay, using your calculator, okay, we will now have the value of 5,362.56 pesos. Therefore, the value of the equipment after 2 years is 5,362.56. Compound interest and continuous compounding. If P represents the principal, I the interest rate per period, N the number of periods, and A the amount at the end of N periods, then A is equal to P multiplied to the quantity of 1 plus I raised to N. If P is the principal or the beginning balance, R is the annual percentage rate compounded continuously, T is the time in years, and A is the amount or ending balance, then A is equal to P multiplied to E raised to RT. Let's have an example. If 50,000 pesos is deposited in an account paying 12% compounded monthly, take note is monthly, how much is in the account at the end of 6 years and 6 months? So we have the 50,000 as our principal. Our interest having a formula of rate divided by the time, that is our rate is 12% monthly divided by our time. How many months are there in 1 year? That is 12 months. So it is 1%. And then our number of periods, that is 6 years and 6 months. How many months are there in 6 years? That is 72 plus 6 months, that is 78 months, okay, or 78 periods. So let's have now our formula. A is equal to P multiplied to 1 plus I raised to N. Our P is 50,000 multiplied to 1. Our N, convert that to decimal, that is 0.01 raised to 78. Using our calculator, we will now have the value of 108,651.86. After 6 months, 6 years and 6 months, we will now have the amount of 108,651.86 in the bank or in your account. Another, if 50,000 is deposited in an account paying 12% compounded continuously, take note, it is continuously, how much is the account at the end of 6 years and 6 months? So again, we have a principal of 50,000 pesos. And then we have a rate of 12%. And then we have years, a time that is 6 years and 6 months, or just say 6.5 years. Okay, because 6 months is a half of 1 year, that's why 6.5 years. Right, so let's have now our formula, that is A is equal to P E raised to R and T. Okay, so our principal is 50,000 pesos. 50,000 pesos. E raised to our rate, that is 12%. Convert that to decimal, that is 0.12. Multiplied to our T, that is 6.5. Okay, so let's simplify our exponent, that is 50,000 E 0.12 multiplied to 6.5, that is 0.78. Okay, using our calculator, we will now have a value of 1,009,073.61. Therefore, the account is 109,073.61 at the end of 6 years and 6 months. Domain and range of exponential function. The domain of the function is the set of all allowable values of x, commonly known as the independent variable or possible inputs of the function. The range of a function is the set of output values, commonly known as the dependent variable, where the all x is in the domain are evaluated into the function. Domain and range of exponential function. If we have f of x is equal to a multiplied to b raised to x minus c plus d, our domain is a set of all x such that x is element of real number. If we put that in our interval notation, that is negative infinity up to positive infinity. If a is greater than 0, our range is a set of all y such that y is greater than d, wherein if we put that in our interval notation, that is d up to positive infinity, where d is not part of the solution. If a is less than 0, our range is a set of all y such that y is less than d, wherein if we put that in our interval notation, that is negative infinity up to d, where d is not part of the solution. That is the basic concept on how to calculate or to solve the domain and range of the exponential function. There are 6 properties of exponential functions. First, the domain is the set of all real numbers. Number 2, the range is the set of all positive real numbers. Number 3, it is a one-to-one function. It satisfies the horizontal line test. Number 4, the y-intercept is 1. There is no x-intercept. Number 5, the horizontal asymptote is the line y is equal to 0 or the x-axis. There is no vertical asymptote. Number 6, the function is increasing if b is greater than 1 and is decreasing if 0 is less than b and less than 1. Find the domain and range of the given exponential function. To solve the domain of the exponential function, always remember that domain of exponential functions are all real numbers. So, that is, domain is the set of all x such that x is element of real number. To write it in our interval notation, that is negative infinity up to positive infinity. That is our domain. As you observe our function that is in the form of f of x is equal to a multiplied to b raised to x minus c plus d, wherein your d is your horizontal asymptote and your a is equal to 3. As you observe, our a is greater than 0. Therefore, your range is the set of all y such that your y is greater than d. And what is your d? That is equal to 5. Your y such that your y is your y is greater than 5. And to write it in our interval notation, that is 5 up to positive infinity, and that is our range. Next example, find the domain and range of the given exponential function f of x is equal to 4 raised to x plus 1. To find the domain, always remember the domain is set of real numbers. So, the domain is the set of x such that x is element of real number. To write it in our interval notation, that is negative infinity up to positive infinity. That is our domain. For our range, okay, as you observe, your a, that is 4, is greater than 0. Therefore, your range is the set of all y such that y is greater than d. But then, there is no d here. Alright, so your d is equal to 0. Therefore, to write it up, that is y, the set of y such that y is greater than 0. To write it in our interval notation, that is 0 up to positive infinity, and that is our range. Find the domain and range of the given exponential function f of x is equal to negative 3x plus 5. To find the domain of the function, exponential function, always remember that the domain is a set of real numbers. Therefore, the domain of the f of x is equal to negative 3 raised to x plus 5 is the set of all x such that your x is all set of real number. To write it in our interval notation, that is negative infinity up to positive infinity. That is our domain. For our range, that is our function is in the form of f of x is equal to a multiplied to b raised to x minus c plus d, wherein your d is our horizontal asymptote, but then we don't have a value of d here in our given function. Therefore, our d is equal to 0. Our a is negative 3. That is, your a is less than 0. Therefore, our range is the set of all y such that y is less than d. And to write it up, that is y, a set of y such that y is less than 0. Since our a is less than 0, our interval notation is negative infinity up to 0. And that is our range. To solve the intercepts, zeros, asymptotes of exponential function, you must know the laws of exponents, solving exponential function, and property of equality for exponential equation. Zeros of exponential functions. It is a value of the independent variable x that will make the function equal to 0. In a graph, it is the x-coordinate of the point intersecting the x-axis. Steps to solve the zeros of exponential function. That is, equate the function to 0. Then solve for the value of x. For example, find the 0 of the given exponential function. F of x is equal to 5 raised to x minus 1. To solve for the 0, we will equate the whole function of the exponential function to 0. That is, 0 is equal to 5 raised to x minus 1. We will transfer negative 1 to the other side of the equation. That is, 1 is equal to 5 raised to x. We will make both bases equal to each other, and 1 is equal to 5 raised to 0 is equal to 5 raised to x. Since they have the same bases, we will focus on the exponent, and that is 0 is equal to x. And that is our final answer. Another, find the 0 of the given exponential function, that is h of x is equal to 3 raised to 4x minus 3 minus 1. To solve the zeros of the exponential function, we will equate that to 0, and that is 0 is equal to 3 raised to 4x minus 3 minus 1. We will transfer negative 1 to the other side of the equation, that is 1 is equal to 3 raised to 4x minus 3. We will make 1 equal to the base 3, that is 3 raised to 0, and that is 3 raised to 4x minus 3. Since the bases are equal, we will focus on the exponents, that is 0 is equal to 4x minus 3. We will transfer negative 3 to the other side of the equation, that is positive 3 is equal to 4x. We will divide both sides by 4 for us to have the value of x. Cancel 4. Our x is equal to 3/4. That is our final answer. Another, find the 0 of the given exponential function h of x is equal to 27 raised to x minus 3. Again, we will equate that to 0. That is, 0 is equal to 27 x minus 3. We will transfer negative 3 to the other side of the equation. That is 3 is equal to 27x. Okay, we will make 27 equal to base 3, and that is 3 is equal to 3 times 3 is 9 times 3 is 12. So 3 cubed raised to x. Since we have the same bases, that is, we will focus now into our exponent, and 3 here has imaginary 1 as its exponent. And that is 1 is equal to 3 multiplied to x. Divide both sides by 3. 3 cancel. Your x now is 1/3. And that is our final answer. Another. Find the zero of the given exponential function h of x is equal to 5 raised to 2x plus 2 minus 1 all over 625 raised to x plus 2. Okay, so again we will equate that to 0. That is 0 is equal to 5 raised to 2x plus 2 minus 1 all over 625 raised to x plus 2. We will transfer this term to the other side of the equation. That is 1 all over 625 raised to x plus 2 is equal to 5 raised to 2x plus 2. Okay, we will make this 625 to base 5. That is 1 all over 5/4. Okay, raised to x plus 2 is equal to 5 raised to 2x plus 2. Okay, so we will make this as a whole number. That is 5 raised to negative 4 raised to x plus 2 is equal to 5 raised to 2x plus 2. Since they have the same bases, we will focus on our exponent. That is negative 4 multiplied to x plus 2 is equal to 2x plus 2. Let's simplify. Negative 4x to x is negative 4x. Negative 4 to 2 is, that is negative 8. Negative 8 is equal to 2x plus 2. We will transfer negative 4 to the other side of the equation and 2 to the other side of the equation. That is negative 2, negative 8 is equal to 2x plus 4x. Negative 2 and negative 8 is negative 10 is equal to 2x, and 4x is 6x. Divide both sides by 6. 6. Cancel. Our x is simplified. That is 5 over negative 5 over 3. And that is our final answer. Intercepts of exponential function. These are the points of intersection of the graph to the x-axis. Okay, so our x-intercept, these are the points where the graph crosses the x-axis. To solve it, we set y is equal to 0. For y-intercept, these are the points where the graph crosses the y-axis. To solve it, set x is equal to 0. For example, find the intercepts of the given exponential function. G of x is equal to 5x minus 125. For the x-intercept, we will set our y equal to 0. But first, we will rewrite our function g of x is equal to 5 raised to x minus 25 into y is equal to 5 raised to x minus 125. Okay, we will set our y equal to 0. That is 0 is equal to 5 raised to x minus 125. 125, negative 125. We will transfer that to the other side of our equation. That is 125. Okay, is equal to 5x. 125 is a perfect cube of 5. Okay, that is 5x. Since we have the same bases, we will focus on our exponents. That is 3 is equal to x, and that is our x-intercept. For our y, we will set our x equal to 0, and that is g of 0 is equal to 5 raised to 0 minus 125. Okay, so our g of 0 is equal to 5 raised to 0 is 1 minus 125, and our g of 0 is equal to negative 124. Your y now is equal to negative 124, and that is our final answer. Another example, find the intercepts of the given exponential function f of x is equal to 3 raised to x plus 2 minus 9. To solve again the x-intercept, we will rewrite the function to y is equal to 3 raised to x plus 2 minus 9, and set your y equal to 0 and equal to 3 raised to x plus 2 minus 9. Transfer negative 9 to the other side of the equation. That is positive 9 is equal to 3 raised to x plus 2. Okay, 9 is a perfect square of 3. That is 3x plus 2. Alright, so since we have the same basis, we will focus on the exponent. That is 2 is equal to x plus 2. We will transfer positive to the other side of the equation for us to have a value of our x. That is 2 minus 2 is equal to x, and that is 0 is equal to x, and that is our x-intercept. For our y value, we will set our x to 0, and that is f of 0 is equal to 3 raised to 0 plus 2 minus 9. Our f of 0 now is equal to 3. 0 plus 2 is 2 minus 9. And then f of 0 is equal to 3 squared is 9 minus 9. Our f of 0 now is equal to 0. And our y value is y-intercept is equal to 0. Asymptotes of exponential function. Drawn as dashed line to which a graph gets closer and closer as the x and y increases or decreases its value without bound. Asymptotes serves as boundary line which the graph of the function approaches. There are three kinds of asymptotes. First is the vertical, second is the horizontal, and the third one is slant or oblique. Horizontal asymptote of exponential function. Graphs as horizontal dashed line. A graph gets closer and closer as the x increases or decreases its value without bound. Exponential function in the form of f of x is equal to a multiplied to b raised to x minus c plus d has horizontal asymptote as the line y is equal to d. If there is no d, then the horizontal asymptote is y is equal to 0. For example, find the asymptote of the given exponential function y is equal to 3 raised to x plus 3 plus 2. Since our function is in the form of f of x is equal to a multiplied to b raised to x minus c plus d, and d is equal to 2, our horizontal asymptote is equal to y is equal to 2. Find the asymptote of the given exponential function f of x is equal to negative 2 raised to x plus 3. Since our function is in the form of f of x is equal to a multiplied to b raised to x minus c plus d, and d is not included in the function, our d is equal to 0. Therefore, our horizontal asymptote is equal to y is equal to 0. And that is our final answer. Find the asymptote of the given exponential function g of x is equal to 3 plus 2 raised to x minus 1. Since our function is in the form of f of x is equal to a multiplied to b raised to x minus c plus d, and d is equal to 3, okay, our horizontal asymptote is is equal to y is equal to positive 3. And that is our final answer. Another, find the asymptote of the given exponential function, that is y all over 2 minus 1 is equal to 4 raised to x minus 1. First, we will simplify the given function, that is y all over 2 transpose negative 1 to the other side of the equation, that is 4 raised to x minus 1 plus 1. And then we will multiply both sides of the equation by 2. Cancel. Your y now is equal to 4 multiplied to 2 is 8 raised to x minus 1 plus 2. And as you observe our new function, that is it is in the form of f of x is equal to a multiplied to b raised to x minus c plus d, and d is equal to 2. Therefore, our horizontal asymptote is equal to y is equal to 2. That is our final answer. To sum up, to solve exponential equation, make the bases equal, then solve the value of x. To solve exponential inequality, make the bases equal, then solve for the value of x. Note, if b is greater than 1, then the exponential function y is equal to b raised to x is increasing for all x. This means that b raised to x is less than b raised to y, if and only if x is less than y. If 0 is less than b and less than 1, then the exponential function y is equal to b raised to x is decreasing for all x. This means that b raised to x is greater than b raised to y, if and only if x is less than y. Domain of exponential function. It is the set of all real numbers. The range of exponential function. It is the set of all positive real numbers. To find the zero of an exponential function, equate the function to 0 and solve for the value of x. To find for the x-intercept, set y is equal to 0 and solve for the value of x. To find the y-intercept, set x is equal to 0 and solve for y. To find the horizontal asymptote is equal to the value of d. If there is none, then horizontal asymptote is equal to y is equal to 0. Again, thank you for listening and watching our video lesson. If you have a question, feel free to PM me in my messenger account, that is Kim Francis Season Alam. See you next week again for our video lesson. Goodbye!